Hello everyone, so today I'm going to be doing another video still on Newton's laws of motion, or at least in that playlist, and today is on terminal velocity. So terminal velocity by definition is the maximum velocity that you can reach or that an object can reach, okay? And when you have terminal velocity, because you cannot reach a higher velocity, that means your velocity stays constant, therefore there is no acceleration. Therefore, the resultant force will be zero when you are at terminal velocity. So, if you go on the video that I put yesterday, so the one with force equals mass times acceleration, you will see all the explanation about why the acceleration is zero and therefore the resultant force is zero, okay? So today I'm going to be telling you about two types of terminal velocity. I mean, it's the same thing, but I'm first going to talk about an object falling through a fluid, and then I'm going to be telling you about a powered object, okay? So something that has an engine to make it fall forward. I have a video there that is quite good because it's quite visual, which is the physics of skydiving. I'm going to put that link there as well. If you don't watch the video, you can still get enough. You can still understand the lesson. But if you watch the video, it's going to have, as I told you, it's quite visual. You see the arrows, the two forces acting on the skydiver. So it's quite useful, I believe. Anyway, whenever you have, you're falling through a fluid, or if you have a powered object, but it has some type of drag, so whenever anything is moving, you're going to face drag. So this is going to work either for the powered object or for the object falling through a fluid. Now, the drag that you have will depend, so that force will depend on the shape of the object, on the speed of the object, and on the viscosity of the fluid where it is traveling through. And remember, fluid is anything that is a liquid or a gas. So that is going to, as I told you, affect any type of terminal velocity. So in between these two is to do with the two of them, okay? The drag is still going to be the same, all right? Now, if you are traveling at a higher velocity, then you have a greater drag force. The reason for that is because drag is created by the particles in the fluid colliding with your object or with you. Now, if you're moving faster, then you're going to collide with more particles per second because you're going to pass through more particles. So therefore, the drag force increases. Now, terminal velocity. This is something that you would have seen in the video as well, but even if you didn't see it, there it is. This is or are the steps for terminal velocity. When you have an object falling through a fluid, the forces that you have acting on the object will be the gravity, because that's the weight of the object, and then the drag or the friction. So the gravity is going to try to pull the object downwards if the object is falling through a fluid, just as skydiving, for example. And the drag is going to oppose to that motion. So it's going to be the force of air resistance or fluid resistance, depending on where you're falling, okay? And that force is going to be opposite to the gravity. When the object starts falling from rest, the force of gravity is going to be greater than the drag. This is because if you are moving slower first you only have gravity, and then as you fall, you start to collide with more and more particles. So gravity is greater than the drag first, okay? And therefore, because the forces are unbalanced, the object is going to accelerate because the velocity of the object is in the same direction at the higher force, the gravity, and therefore the object speeds up, so it accelerates. Then, as the object accelerates, the drag is going to increase because you're moving faster, so you're going to hit more particles. So therefore, the resultant force decreases. The resultant force is the adding of the gravity and the drag, taking the direction into account. So if I first have almost no drag and only gravity, and then my drag increases, obviously, if I do gravity minus the drag, that number is going to be smaller than in the beginning because my drag is bigger. So the resultant force decreases. Then finally, when the drag force equals the force of gravity, so when they are equal and opposite, the forces are going to be balanced because they have the same number, but they are going to cancel each other out, given that the direction is opposite. So the resultant force is going to be 0. When the resultant force is 0, remember Newton's second law, force equals mass times acceleration. If the resultant force is 0, the object cannot accelerate any further because it has no acceleration, and it moves at its stop velocity, and that velocity is known as the terminal velocity. So it cannot go further than that. That's why it's the name terminal. Since the acceleration is 0, the terminal velocity remains constant. Unless, of course, I change something, change the shape, change the drag, for example, open a parachute, any of these things. But if I keep the same conditions, then the terminal velocity is going to stay constant, okay? If you want, you can investigate drag yourself. You can get a fluid, an object falling through a fluid, and all that you need to do is to attach the object to a ticker timer. The ticker timer is going to be printing dots onto a tape at a constant rate, and then you will see that the dots are going to be spaced out in different amounts depending on the velocity that the object is falling, okay? If the dots are closer, then the object is falling slower, okay? So this is what is happening. Each number, 1, 2, 3, up to 7, is represented here, and this is how the shape of the graph is for an object reaching terminal velocity. If you look, I still have a gradient first, so meaning that I'm moving a little bit faster. Sorry, no, this number is slower, sorry. No, but I mean, oh my god, this went so bad. So what I mean is, because I have a gradient here, the number is smaller, but the gradient is increasing, so my velocity is increasing, sorry. And then here, I have more of a horizontal line, so that means that I'm reaching constant velocity. So first, I am going slower, my speed increases, but here the shape of my gradient, or because I have a gradient, it shows not that I have a higher speed, but this gradient is going to tell me that the speed is increasing at a faster rate first, and then as the gradient gets shallower, then my speed is increasing at a slower rate. So sorry for the confusion there. And then the actual formulas for the resultant force. So resultant force is going to be the mass times the gravity, so the weight minus d, the drag, and it's going to be equal to the mass times acceleration. So I decided that the drag facing upwards was going to be negative, okay? If I rearrange, I get that acceleration is my resultant force over the mass. So my acceleration will be mass times gravity minus the drag over the mass. So that means that I can cancel out the masses from the gravity side, so I get that my acceleration is going to depend on the gravity minus the ratio in between the drag and the mass of my object, okay? Finally, imagine that I have a powered object. I can do exactly the same calculations, I just need to add a new force, okay? Which is going to go in the same direction as the movement. So the terminal velocity will not only depend on the shape, but also on the power, on that force, okay? On the engine power, okay? If I get a more streamlined object, then I will also be able to reach a higher speed because, as you know, drag depends on the shape of the object, and I will allow the particles to slide through easily. Oh my god, today I cannot speak. If the object is more aerodynamic or streamlined. So the force, the resultant force, is going to be the force of the engine minus the resistive force, and that's going to be equal to the mass times the acceleration. Again, I'm going to make acceleration the subject of my equation, so I get that acceleration is the engine force minus the resistive force divided by the mass, okay? And then as my car accelerates, the frictional forces increase, so the resultant force decreases. So this number gets bigger, so this number overall gets smaller, okay? Eventually, if these two numbers are the same, they cancel each other out, so I get a 0 on the top, so my acceleration will be 0. So I reach terminal velocity. Terminal velocity is reached when acceleration equals 0, which happens when the force of the engine equals the resistive force. So that is it about terminal velocity. I hope it made sense. Sorry about the confusion there. That's the thing, when you're doing the videos, sometimes you just say things and then you only realize you said them after you said. It's like a normal conversation, really. It's just that is recorded on the video. Anyway, be happy and healthy until my next video, and take care. Bye.